Okay, we're going to be starting lesson 210 today. And what we're going to be studying is we are going to be looking at different percentages. We're going to try to find the percent of change. And then we are also going to be looking at what's called relative error. Okay? All right, so the first thing we're going to study is percent of change. And it's expresses an amount of change as a percent of the original amount. Okay? And there are going to be two types of change that we are going to really be looking pretty hard at. We have a percent, what's called percent of increase, and we have percent of decrease, okay? And think about percent of increase would be like sales tax. So like when you go to McDonald's and you buy something off the dollar menu and it's $1, well, when you have tax on top of it, in Indiana, it's 7%. So that means we would end up paying $1.07. Okay, so sales tax is something where we're going to be adding on the amount. Percent of decrease would be like discount. So if you're buying like a coat for 30% off, so it'd be at a discounted price. Okay, there is a formula that you're going to need to know for this. And I always talk about it's difference over original equals your percent out of 100, okay? And right here, when I say difference, I am talking about we are going to subtract, okay? So when we talk about difference, we're actually going to be subtracting the two amounts, okay? And then hopefully we know that percent is always going to be out of 100 parts. All right, so let's look at an example here. Example 1. A coat is on sale. The original price of the coat is $82. The sales price is $74.50. What is the percent of decrease? So now on this, they have already told you that the price is going down. You started at 82, you went to 74. So that is going down. Okay, on your homework, they're not always going to give this to you, and they're sometimes going to ask you to say whether it's increasing or decreasing. So you just need to look at your numbers and say, is it going up or down? Well, in this case, 82 to 74 is going down, so it's percent of decrease. All right, and now we're going to use our formula, difference over original. Okay, so difference, I'm going to take 82 minus 74.50. And when I subtract that, that's going to give me $7.50, okay? So now difference, $7.50 over the original price of the coat, 82, equals, percent is what I'm looking for, over 100, okay? So just kind of keep in mind here that this guy is going to be right here. You got to subtract for that top number. So now you're just going to go ahead and cross multiply. So we're going to take, oh, I didn't want to do that. Let's back that off a little bit. Let's go back to the writing. We're going to take this guy and multiply. So we're going to end up with 750 equals 82x, and then divide by 82 on both sides. So my answer here is going to be 9.15%. Okay? Now, pay attention on your homework to the directions, because sometimes they're going to ask you to round to the nearest whole percent, and if that were the case, then you would just call this 9%, okay? Now, on a test or a quiz, though, usually we're going to say round to the nearest hundredth, since that's what we've been working on this whole time, so you're going to want to include that 0.15. So just pay attention to directions on your homework. Is it asking for the nearest whole, or is it asking you for the nearest hundredth, okay? And then also keep in mind that we are going to sometimes be asked to say whether it's increasing or decreasing. All right, so let's look at another example. A store buys an electric guitar for $295. The store then marks up the price of the guitar for $340. What is the percent of increase? So again, on your homework, they're probably going to ask you to say that this is an increasing amount. I went from $295 to $340, so it's increasing. Now, in this case, they've already told you, so we don't have to write that down. All right. Okay, so let's go down through here. Kind of keep our numbers here so we can see them. We know that the first thing we're going to do is we're going to need to subtract. I don't care which way you subtract. You just need to get the difference. So it's not a specific order like original minus, oh, didn't need that zero, did I? It's not like a specific order like bigger or smaller or anything like that. Just subtract and find out that they're 45 units apart. That's all you need to do, okay? So now difference is 45 over the original, which is 295. Equals, percent is what I'm looking for, over 100. Okay? All right, and then you're going to cross multiply and get 4,500 equals 295x, and then divide by your 295. Kind of running out of room here, aren't I? Okay, so then X will equal 15.25%. And that's going to be my final answer. Again, on your homework, if it asks you to round to the nearest percent, you would be rounding this to 15% if it says in the nearest whole percent. Okay? All right, the next thing we're going to be looking at is called relative error. Okay? So now relative error is the ratio, so fraction, think fraction, and we'll kind of look at it down here, of the absolute value, something we studied in chapter 1, absolute value, of the difference of the measure or estimated. Okay, so it's just usually we estimate the value. And then an actual value compared to the actual value. Okay, so what's important right here is, oh, come on, little guy, the formula. Okay, so relative error. Okay, notice how I have absolute values, and the absolute values are just on the top part. We're going to take the estimated amount, whatever it might be, whether we've measured it or whether they've given it to us, an estimated amount minus what it actually ended up being. And then we'll divide by the actual. Okay, so when relative error is expressed as a percent, we call it percent error. Okay, so right here, make sure you write that in, percent error. Okay, so let's go over to the next page. And so example 3 here, a decorator estimated that the rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? Okay, so when we're looking at this, first thing that we've got to notice is it is asking us to find area. Okay, so right here, find this guy, find the area part. That's the important part there, okay? So now, since we're doing area, sorry, trying to zoom in here. So when we're doing area, okay, think about what the area of this guy would be, right? 5 times 8 would be 40. And then the actual area ended up being 4 times 8, or 32. So we estimated it to be 40, but it actually was only 32. So our estimate was pretty far off. I mean, it was pretty large, okay? So now if you're thinking about relative error, we have the absolute value, estimated, right? We're going to do the estimate minus the actual, okay? So estimated was 40 minus the actual, which is 32. And then you're going to divide by the actual number, which is 32. So this would be actual, okay? All right, so first thing we're going to do is we've got to go ahead and we're going to subtract the inside and get 8. So right now I've got the absolute value of 8 divided by 32. Well, in this case, the absolute value of any number is going to be positive. So I have got 8 divided by 32. Now you're going to go ahead and divide this on your calculator and find out that it's 0.25, okay? Now, since it's asking for a percent error, I need a percent. So 0.25, we're going to call it 25%. And that's our answer. Okay, now let's take a look at another one of those. Okay, you think that the distance between your house and a friend's house is 5.5 miles. The actual distance is 4.7 miles. What was the percent error in your estimation? Okay. So again, let's kind of zoom in here. All right, so absolute value, start with absolute value. And we're going to take what we thought it was, which was 5.5, minus the actual 4.75 in absolute value. And we're going to divide that by the actual. Okay, so again, take estimate minus actual, and then put the actual on the bottom. Okay? All right, so now absolute value of, take 5.5 minus 4.75 and get 0.75 divided by 4.75. Now, please note, I know neither one of these have it in there, but there are times you are going to get a negative 7.5. If that's the case, make sure when you take the absolute value of it that you get a positive. Remember, absolute value will always give you a positive. Okay? So now we're going to look at this, and so it's going to be 0.75 divided by 4.75. So now just take your calculator, divide it out, and I'm going to round it 2 decimal places, so 0.16. So it ends up being 16%. 16%. Okay? All right, and the last thing we're going to look at is it's going to ask us to find minimum and maximum dimensions. Okay? So You are framing a poster and measure the length of the poster to be 18.5 inches. To the nearest half inch, what are the maximum and minimum possible lengths of the poster? Okay, so when we're looking at this, we have got a total of a half inch that we can be off, okay? And it's, when we're thinking about it, it's not a half inch in either direction. It's a total of a half an inch, okay? So what I want you to think about here, so let's zoom in. Okay, a half inch would be the same thing as 0.5, right? 0.5. And what you're going to do is just divide it by 2. And you're going to find that you can go 0.25 inches in either direction, okay? So this would be in one direction, if you want to think of it like that. All right, so if I want to find out what my minimum's going to be, I'm going to take the 18.5, and you're going to subtract off the 0.25, and you're going to end up with 18.25. And then I'm going to take the 8.5 now and find the maximum. So this was min. I'm going to find the max. And I'm going to add the 0.25. And so when I do that, I get 18.75. So now notice how these are a half an inch apart, okay? So that's why we're kind of dividing by 2. We're going to go a half an inch down and a quarter of an inch up, down, dang it. A quarter of an inch down and a quarter of an inch up, okay? And these guys right here would be your minimum and your maximum. All right, so let's try that one more time. A student's height is measured in as 66 inches to the nearest inch. Okay, so nearest inch on this one. What is the maximum in? Okay, all right, so if I'm thinking about I have 1 inch, and dividing it by 2, well, obviously you can leave it as 1/2 or you can call it 0.5, whatever you want to do there. Okay, so the height was 66. To find the minimum, I'm going to subtract off 0.5 and get 65.5. To find the max, I'm going to take 66 and I'm going to add the 0.5. And so we end up with 66.5. Again, notice how they're an inch apart. Okay? All right, and that concludes the notes for lesson 210.